Okay, hello, this is Bob Jackson with SC201. We're going to hit Chapter 7, Light and Electromagnetic Spectra. This is, well, for one thing, I just kind of let you know right off that we're not going to go real deep into this unit. Okay, and you'll see if you actually read Chapter 7 and look through Chapter 7, there'll be a good bit that we don't really go into. And like I did with Chapter 5, I'm going to sort things out here that try to make grade level appropriate. Okay, but I do think there are important things to teach students about light and electromagnetic spectra and keep it at level for elementary. Okay, and in alignment with the Indiana academic standards and what I think is grade level appropriate and that students can understand. I do think that light and electromagnetic spectrum is very, very important in the world today. A lot of the toys, the gizmos, the things that kids have today, and not only kids, but people have today are totally dependent upon uses of different types of electromagnetic spectrum. And even more than that, even a lot of medical applications. If you're going for different types of scans and so forth, your body's getting exposed to different types of electromagnetic radiation to analyze your body. And it'd be nice to get people to somewhat understand what that's all about and what's going on, and then just the basics. Okay, and that's all I want to do is kind of keep the basics. You'll see that this unit, there's not that many slides in this PowerPoint, but there's some essential things I want to teach. So I want to start out with talking about white light and sunlight. Go into the electromagnetic spectrum, what makes up the electromagnetic spectrum, what we use the different types of electromagnetic spectra for. Talk maybe just a little bit about interactions with the light, what light does, and so forth. Just kind of naturally do that, talking it. And then end with the different types of light bulbs that we have. Not all of them, just the three basic light bulbs, because there are several. I mean, you can go into sodium vapor lights, halogen lights, and some of the different theater lights and so forth. We aren't going there. We're just very basics. Okay, because I would like for kids to know and understand the very basic types of lights, okay, or light bulbs. Okay, so let's get started. First thing to start out with is white light. Okay, white light's all around us. Okay, white light's important. It's important to get kids to understand what white light is. And I think this all the way down to the primary grades that really start talking about doing things with white light, because anytime you're dealing with collars and doing stuff with the primary collars, you're talking within what we call white light. But white light is an equal amount of all the colors of the rainbow. If coming to my eyes are equal amounts of all the colors of the rainbow, I'm seeing white. Okay, if I get more one than the other, then I start seeing the other hues of color. Okay, and that's like at a sunset, a really nice sunset, and you got some moisture in the air and humid Indiana, or you out down in Florida on the beach and watch a nice sunset over the water. What that sunlight's coming through and the sky acting somewhat to filter that light out, you start seeing some colorful sunsets because that light's been filtered through the sky at the angle that it is and so forth. And then rainbows are where you got moisture in there, droplets and in the clouds and so forth that are making the sky act like a prism. Okay, but you can take, like on this slide, you can take and prove to students that what white light has in it by taking a flashlight and shining it through a prism. But if you haven't got a prism, just take you a glass and put some water in it and shut the lights off in the room, shine the light through it, and somewhere up against a wall or across the tabletop or something, you're going to see a rainbow. But there's also times you can see a rainbow made when the sunlight comes through the window of the classroom and on the floor. And whenever you see that happen, just even though you're not on the unit, kind of show the students. Okay, and if all these colors weren't there, you wouldn't see it. Okay, they're all coming from white light, and they'll always be, point out to them, they'll always be in the same order. Okay, it won't be next time you see them red, it's gonna be down here, they're gonna all be mixed. They're always gonna appear in the same order relative to their energies. And you can go however talk like violet has the highest energy, okay, and red the least, but they still stack up. Okay, they're in order in the spectrum, and they'll always be that way. Okay, just like a rainbow. Rainbow always form the same way. Now, it might not be as bright and so forth because of other factors, but the colors of the rainbow are always in the same order. Okay, that's white light. Okay, here's the biggest and most important thing of all that we teaching, and that's the electromagnetic spectrum. Okay, the electromagnetic spectrum is a full range of radiation waves. Okay, and there's different types, and that's what I want to teach is the different types and what we use those different types for. Okay, now there are two characteristics of all electromagnetic radiation waves that make them electromagnetic radiation waves. They all have a frequency and they all have a wavelength. Okay, and the frequency and the wavelengths determine everything about them and what they can do and what they can't do, what they can be used for, what they can't be used for, and also whether they're harmful or not. Okay, so that's where I want to talk some of this. If you take a look on here, you see the wave pattern going across here, going from small wavelengths to large wavelengths. Okay, but also along with that, you got to imagine these are really moving. Okay, so this is small wavelengths, but it's high frequency. Okay, high frequency and number of waves pass a point per minute. Okay, this high frequency. Okay, this would be low frequency. Long wavelength, low frequency. Short wavelength, high frequency. Okay, so now that goes hand in hand. If you have high frequency, you have low wavelength. If you have long wavelength, you have very short frequency. Okay, or low frequency. Okay, but now then what's opposite of that is you take energy. High frequency, very high energy can be very dangerous. Low frequency, it's less dangerous, but it's also low energy. Okay, so like the waves that are coming to here to my phone to make this thing work, relatively low energy. Okay, so it's not harmful to me. Don't want it to be. For this is to my car. When I start pushing the buttons on it, each button puts out a different frequency of energy. Those are electromagnetic waves, low energy, long wavelengths. Okay, whereas if I get down into some of them like gamma rays, extremely high energy and very high frequency. Okay, so now then looking at the spectrum, I want you to know each of the types and relatively something about their wavelengths and frequencies. Like the highest frequency radiation wave is gamma rays. The lowest frequency are radio waves and actually radar waves, okay, which aren't listed on here. Okay, but these are very high frequency, very low frequency, very long wavelength, very short wavelength. Okay, so now then, know them in order. You go from gamma rays to X-rays, then UV. The shortest range on the electromagnetic spectrum is visible light. Okay, what we can see. Then you have infrared, and then you have radio waves. That's going from very short wavelengths to very long wavelengths, from very high energy to very low energy. Okay, that's the electromagnetic spectrum. And I think it's important to teach these kids because we use these, and that's what this next slide's about. What do we use this stuff for? Okay, if we come down here to gamma radiation, which one I don't like that they don't have on here. Yeah, you can have gamma ray is in the, can be in some of the things like lightning and arcs within things. But by far the most common as far as what we use is radiation treatments for cancer, where they destroy cancerous tumors. Very controlled environment, try to make it as safe as possible and very focused right on a tumor. Okay, so that's gamma or gamma knife. You'll hear them talk medical applications. Okay, X-rays, 4 X-rays. Use X-rays, 4 X-rays, but you also use them for CAT scans. CAT scans are 3-dimensional X-rays. Okay, so that's something you can tell the kids. X-rays are called X-rays because it's a type of electromagnetic radiation used for that. Then you have ultraviolet. Ultraviolet naturally comes from the sun, causes sunburns, causes skin cancer and stuff like that. But you also have UV lights that you use for killing germs. They're in kitchens, they're in hospitals, they're in operating rooms, and places like that. They also use some UV lights to see things that are regular that we can't see without using UV lights. Okay, almost like a black light, although a black light isn't a UV light. It's close though, because it's on the purple spectrum. But they'll use them in criminology to survey a scene because they can see things with that ultraviolet lights that you can't see with regular light. Visible light, it's the shortest range of the entire spectrum, but everything we see is within it, and all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Infrared has become huge today. Okay, we have infrared remote controls. We have infrared night vision stuff, infrared cameras of all kinds of stuff. Infrared used on satellite technology to see stuff down here on Earth that you can't imagine what our military can see all over the place now because of infrared technologies, not only on satellites, but in airplanes. Okay, flying over in reconnaissance missions and stuff like that. So infrared's used for a lot of things now today. Microwaves for microwave ovens, by far the most, but it's also used, microwaves also used in some communication stuff, and even cell phones have some microwaves going on with them. Okay, and then radio waves is by far one of the biggest. Okay, because all our radios, whether you're talking AM, FM, or XM radio, those are all huge, a huge area today to a lot of our remote controls, whether it's like a garage door opener and TV remotes and so forth. Most of them are operating off of radio waves. Okay, very important. Okay, so I'd just like to know types of electromagnetic radiation and uses. Okay, let's go to light bulbs. Okay, I want students to know, I want you to know the 3 basic types of light bulbs. I always like to use this one. Okay, I've had it for years. This is an incandescent light bulb. Like for students to know what an incandescent light bulb is, it's the one with a filament in it. Okay, right there inside of this one's got 2 of them. Actually, most of them just have 1. And that filament is only made of one thing: tungsten, because it's unique. When I pass electricity up through that, it goes through the tungsten. That tungsten heats right up to white light, perfect white light comes off that. And that's how light's formed from an incandescent bulb. Okay, but the only problem is it can't do it in the air, because if air hits the filament, it'll explode. So that's why we have a bulb around it. You have a glass bulb around it. It has to be glass because it gets hot. Okay, if it was plastic, it'd melt. Okay, and then inside there you have just a little bit of an inert gas that's showing you on the slide, which is most usually argon. It's got to be anything but oxygen. Okay, for the most part. So it don't react with the filament. Oxygen reacts violently with the filament. It'll blow the bulb. Okay, that's an incandescent bulb. Pass electricity to a piece of tungsten. Okay, made into a filament or an element. It glows white heat. If I use any other metal, it glows red, which isn't very good light. Okay, that's an incandescent bulb. Okay, you go to the next one is a fluorescent light bulb. Fluorescent light bulbs are always tubes because they are a cathode ray tube. They're a type of cathode ray tube. They may be coiled like the compact fluorescent, but they're still a tube. Okay, and that tube is because you shoot a beam of electrons down through it. So what these red things are, they should have made them go all the way because they go from one end to the other. Okay, you got a negative end, you got a positive end, and electrons shoot down. When the electrons shoot down through there's a beam, you put a little bit of mercury in there. when the electrons hit the mercury gives off UV light. Just naturally happens. If you stop right there, you got a UV light, and that's exactly the way a UV light bulb's made. But if you put a phosphor coating on the bulb, you make it a fluorescent light. Okay, because phosphor will glow when the UV light strikes it. Okay, and these are much more energy efficient than a incandescent bulb. But where we're starting to do away from with them is because of the mercury factor. Okay, but they are much more efficient, and you still see them around quite a bit, particularly in schools. Okay, but that's it. Very little energy. It is not true white light. You'll have more blue colors off of it than any other color. And if you have a spectroscope, you can look at them, you can see that. I always did as a chemistry teacher, had students look at the lights, okay, with spectroscopes. Okay, and then the last one is LED lights. Okay, LED is light emitting diode. And that's where in a light emitting diode, these are by far the most energy efficient because it requires very little energy to make this happen. You have a diode down here in the bulb, not a filament, but a diode. A diode is made up of a semiconductor. Okay, now then, the semiconductor here, you get a buildup of electrons when you turn electricity on here. You get a buildup of electrons here, and they're going to jump across this gap. When those electrons jump across this gap, they emit light, and that's all it is. It's almost like a lightning bolt, really. Okay, when this jumps across here, okay, that's the lighting. When electrons come up this, go across this gap, jump across here, they emit light. The color of light is totally dependent upon what the diode is. That's a light emitting diode. That's all there is to it. The unique thing with them is it takes very little energy to make it happen. Okay, and that's it. That's wraps it up. We went through the electromagnetic spectrum, the uses of electromagnetic spectrum, breakdown of white light, and then hit the light bulbs. And just on the light bulbs, I'd just like for each of the kiddos to know the basic types of light bulbs that we have, very basically how they work, and then which are the most energy efficient. Well, the LED. Okay, and then, but now if you're raising baby chickens or any babies in a box and you need some more, an incandescent light bulb, you need to do it because an LED won't. Okay, that's it. Have a good evening.